So basically, you're going to take the value of x, and for the first coefficient you're going to multiply it by simply 1 times x. For the second coefficient you're going to multiply by 1 times x times x. Third is going to be 1 times x times x times x, etc. It's not going to make a real difference unless you have big polynomials. And then trade-offs we've looked at so far are not the best trade-offs. But let's evaluate this polynomial at, or maybe this. Let's evaluate this polynomial at 3 different points. Maybe evaluate poly at okay, at -1, the first 2 terms cancel. You're left with 5. At 0, only the constant remains, and at 1, everything adds up, so you get 7. Okay, that works. Okay, so now we can derive basic functions in terms of polynomials. I mean, we can derive the very specific kind of function, which is polynomial functions. And we can derive, evaluate, multiply, so we can make bigger polynomials. So if we have a double, should be able to make it into a polynomial by okay. So now we can make a constant. We can also make var x. So we can make the polynomial x, we can make the polynomial constant. of the ways of making this much more convenient is to have a function which basically takes a string, for example 0, 1, 3, right, and turns that into the polynomial which corresponds to that. So x plus 3x squared. The basic idea is that these polynomial construction procedures will probably never be an issue when it comes to performance. They can be pretty slow, you know. They could take like a few milliseconds. It wouldn't matter because you're just going to call them once, and yeah. So the best trade-off possible in this case would be something that's really convenient to use, that allows you to quickly describe what you want. So you have this easy representation which gets converted automatically to the fast representation, and then you do the computation with the fast representation, and you put the result, you present the result in the easy to understand representation. So that's one thing that can be done, and maybe we'll do it, or we'll do something else, who knows. But now that we have polynomials like this, we're going to be able to talk about interpolation in a way that's a bit more satisfying than we could have done without polynomials. I mean, everything can be done without introducing polynomials. You can just keep an array of coefficients yourself, and whenever there's a polynomial-ish thing, you can do it without ever defining it as such. You can just write, you know, this code wherever you need to write it. But polynomials can be thought of as a concept in mathematics. It's good to have the equivalent concept in the computer. You know that it's not true that, say you want to model a chair. Well, there are lots of things that the chair has that you don't need in a program.